And let's go from current slide. And there we go. The announcements, I don't know of anything too major. I think I announced it before, but if I didn't, I should have. Hopefully everyone has completed payment because they have been removing students, unpaid students, from the rolls. And once you're removed, you sometimes can get back. I won't say it's impossible, but it's just sort of a hassle. So please, if you haven't completed your payment, get that done immediately, if not sooner. And the other thing is, come the end of the term, if you haven't done your payment, no way we can give you a grade because you're not on the official roll. So you've been sitting here all this time and get absolutely nothing from it, okay, except the camaraderie of the fellowship of the other students here. That would be almost worth it. Okay, let's catch, this is D'Angelo here, and Tammy, got it. There, and one more came in, yeah. Okay, got it. Zaria, right? Okay. Anyone else? They came in a bunch there. I got you earlier, right? Okay. Okay. Let me see. Any other issues? Oh, our best volleyball team ever last year won more matches than any other team in school history. They're back again this year, about half of them anyway. The same coaching staff, great. In fact, one of our classmates is a volleyball player. But they have a match this evening, Birmingham West Campus in Arthur Shores Fine Arts Building, which is also our gymnasium and weight room and swimming pool, Fine Arts Building though, okay. But they're there. I can't remember the time, either 5 or 6. Check the schedule and see. I have it in the other classroom. I forgot to bring it in here. So they're playing this evening, so go cheer them on. Coastal Alabama East. What the system has been doing is merging lots of colleges, and they merged some down south that they evidently schools had volleyball teams before, so the East and the West are keeping separate teams, I guess. I don't know. Okay. Lindsay, right? Okay. All right. Anyone else come in since I called roll? So, I'm sure there are other announcements. I just can't think of them right now. Anyone know of any? Okay. Well, where we left off last time, we're still in Chapter 1, Functions in the Graphs, but we're on the vocabulary part of 1.7, which is transformation of functions. We finished the section, but we didn't get to do the vocabulary, so let's do those now. Page 72, 4 questions, but multiple parts on several of them. Number 1, horizontal shifts, vertical shifts, and reflections are what kinds of transformations? Rigid transformation, okay? Number 2, a reflection in the x-axis of a graph y is equal to f of x is represented by h of x is equal to what? Reflection in the x-axis of the graph of y is equal to f of x, what would h of x be then? Negative f of x. Very good. While a reflection in the y-axis of y is equal to f of x would be represented by h of x equal f of negative x. Perfect. All right. Yeah, Jeremiah got it. Okay, I know you're in here. You're hiding those. There you are. I got you. All right, anyone else come in since the call roll? Okay. We're doing the vocabulary after 1.7 on page 72. We've just done the first two. Number 3. A non-rigid transformation of a graph, y is equal to f of x, represented by g of x is equal to c times f of x. C times f of x is a blank blank when c is greater than 1. C is equal, g of x equals c f of x is a blank blank when c is greater than 1. Vertical stretch, perfect. And a blank blank when 0 less than c is less than 1. Vertical shrink, okay? That would be a psychologist on the bench. No, that's not right. Okay. Standing up. Okay, here's the other Tyler. We have. Okay, good deal. And? What's that? Oh, that's true. They opened the door this morning but didn't unlock it, so that's where he's noticing that. The next person would have been locked out. And that's what I do for late arriving students. I'm just kidding. Okay. All right. What's your name? Huh? Ty. And? Sure. Okay. Okay. Ty and Sharona. Okay. Yeah. No. They'll close it all the way. For some reason, when they opened it this morning, they locked it back. And your name, please?
Amari. Amari.
Amari, got it. All right. Okay, shaping up to be a good-sized class today. All right, we're doing the vocabulary in 1.7 on page 72. We've just done 1, 2, and 3. Here's number 4. Number 4 is a matching, so it's going to be hard for me to read it. Hopefully you got your text and you're looking at it. It says match each of the following, match each function h with the transformation that it represents where c is always greater than 0. So you tell me what kind of transformation this would be. H of x is equal to f of x plus c. It's vertical, I heard someone say. Vertical what? Say again? Right? Yeah, okay. Vertical shift up. You're absolutely right. Okay? H of x is equal to f of x minus c. And by the way, that would have been 4, the first one. H of x is equal to f of x minus c. Vertical shift down c units. So that would have been Roman numeral little number 2. H of x is equal to f of x plus c. And here's Josh, but I've just got to find them. There you are. Okay, I heard somebody say something, but I couldn't make it out. Horizontal shift to the left. You got it. Okay. That would be little Roman numeral 3. And h of x is equal to f of x minus c. To the right, okay. F of x minus, that would be a horizontal shift C units to the right. Any question on those? Okay. With that done, we're now ready for 1.8. Okay. Chapter 1, functions in the graph. 1.8 is combinations of functions, and I don't agree with the colon here, composite functions. Okay? These are two separate issues here. We're going to do combinations of functions first, then I would say a comma or maybe a semicolon or something, then do composite functions. Composite function isn't a type of combination of function. It's a new animal. You've done combinations really before, whether you know it or not. You probably haven't done composites. So let's go with that. The objectives here, these are the combinations of functions. Adding, subtracting, multiplying, and dividing functions. Doing our basic four numeric operations, but doing them on functions. Then the next is finding the composition of one function with another function. Okay? Get your name, please. Amber. Okay. Good deal. All right. That's probably going to be the new one for you. Okay? If not new, it'll be a good refresher. And then we'll use combinations and compositions of functions to model and solve some real-life type problems, and that will come toward the end of the section. So let's start with arithmetic combinations of functions. Just as any two real numbers can be combined by operations of addition, subtraction, multiplication, and division to form other real numbers, so two functions can be added, subtracted, multiplied, or divided to come up with new functions as well. Okay? So that's where we're going to start. For example, here's a function, f of x equal 2x minus 3, okay? And g of x is equal to x squared minus 1. They can be combined to form the sum, the difference, the product, and the quotient of f and g, okay? Now, there'll be a few little things we have to worry about, not right now, but a little bit later, and we'll discuss those when we get to them. So for instance, the sum of those two functions, f plus g, is f, 2x minus 3, plus g, which is x squared minus 1, and that's simply adding like terms, right? X squared is the only squared term, 2x is the only, plus 2x is the only linear term, and then minus 3 minus 1 is minus 4. There's a constant term. There's the sum of those two functions. It's also a function of x, okay? Pretty straightforward, hopefully exactly what you would expect, okay? Any questions on that? Pretty easy, okay? Same two functions, let's do f of x minus g of x. Now I want to point something out to you, so let me go back. The way they wrote this, they put these in parentheses. The f function in parentheses, the g function in parentheses. Actually, a leading parentheses actually does absolutely nothing for you, just sets it off as a function, okay? First thing I would do would remove it, okay? When a parentheses follows a plus sign, that does absolutely nothing for you. It just groups them together. That's all it's doing. So you just combine like terms just like we did. However, when you're subtracting, especially with that second function, the one following the minus sign, you pretty much got to put that in parentheses. Again, these parentheses do absolutely nothing for you, but this one does. Because what does that minus sign do? Yeah, you change the sign of every term inside the parentheses. Nothing changes here. This is x squared. I wish they had worked this out. In fact, I guess let's go on and us work it out. Okay? This would be, like I said, let me get my pen set up. Okay. This one, the parentheses do absolutely nothing for you. Is it Katie?
Yes.
Okay. I was telling the classes a match today. What is it, 5 or 6? Is Coastal Carolina? Coastal Alabama. Yeah.
We play at
5. Okay.
Yes.
So I'll be at 5, the gym on the Birmingham West Campus. Okay. So this parentheses here does absolutely nothing for you, so just remove it. 2x minus 3. But the minus sign before parentheses changes the sign of everything in the parentheses. So this will be a minus x squared minus a minus is plus 1. So when you combine those like terms and put them in descending order of the powers, you start out with a negative x squared, then a plus 2x, and then when you combine a negative 3 and a plus 1, that gives you a negative 2. Right? Now, when you're multiplying two functions, just like you would expect, put one in parentheses times the other. Now, usually parentheses next to each other means multiply, and that's exactly what it is. What would be your technique for multiplying those two? Good old FOIL. Exactly. Okay? So let's do that. They just put down the answer, which to me is not very useful. Let's do the first, and that gives you what? 2x cubed, did I hear? Okay, let's do the last. Well, actually, I'm not going to spell it right. I'm going to do the inner first. Okay? I'm not going to do the outer, I'm going to do the inner. What does that give you? Negative 3x squared, right? Right? Okay, then I'm going to do the outer. And what's that? Negative 2x. And then finally I'll do the last. Plus 3. Okay. Now the reason I chose to misspell FOIL is because I wanted to get the x's in descending order of power. Doesn't matter which order you do them, they're all adding and subtracting at the end, so that's what you get, and sure enough, that's what they got. 2x cubed minus 3x squared minus 2x plus 3. Got it right, so we get a happy face. So good deal. All right, now, here's where the little bit of a problem occurs. When you're dividing f by g, anytime you divide, what do you have to watch out for? What can you never divide by? 0. So then you have to make sure, don't close it all the way because they didn't unlock it. Thank you. Mark. Second. Raquel, got it. My hearing is so bad. Okay. Anyone else come in since I called roll? Okay. We're doing example 1. No, we're doing the we're doing the top part of page 76. This is chapter 1, functions of the graph, 1.8, combinations of functions and composite functions, and we're just doing the I guess they're not called examples, but the illustrations at the top of the page. Now, here's what we're worried about, or not worried, but have to concern ourselves with. You cannot divide by 0. So any values for x that would make that denominator equal 0 have to be disallowed. Didn't matter up here. Adding, subtracting, multiplying. You could add, subtract, and multiply by 0 anytime you want to. No problem. You just can't divide by 0. Okay. You can have 0 in the numerator, no problem. But you can't have 0 in the denominator. So what values of x would make this denominator equal to 0? Any? All right, let's see. We can't have it equal 0, so I would say x squared minus 1 cannot equal 0. Okay? How would you solve that inequality? Okay, you could do that, and we'll come back and do it. A little bit better way, though, is to, what's your F word? Factor. Is that factorable? Yay or nay? How? x. Second? Okay. Okay, wait just a second. Huh? Lee? Richard, right? Okay. All right, good deal, folks. Now, I wasn't hearing well. Say again, whoever was saying. Okay. We're factoring this. Is that what you're doing? X squared minus 1? It's what? X plus 1 times X minus 1. That may have been what you were saying. I just couldn't hear. Okay? All right. If that product can't equal 0, what does that tell you about the values? Neither one of them can equal 0, can they? So that means that X plus 1 cannot equal 0. And before, if that was an equal sign, we'd say or. Now we say and, because it's not either or. Both of them, neither one of them can equal 0. X minus 1 cannot equal 0. Neither one of them can. What do you get with the first one? Say again? X cannot equal negative 1, and X cannot equal positive 1. Now, how do you get that? You add 1, subtract 1 from both sides here, add 1 to both sides here. Right? So, that's why they say X cannot equal either plus or minus 1. See, they wrote it down there, but they didn't show you how they got that. Okay? So, you can add, subtract, multiply any two functions you want to, but when dividing, you have to restrict the denominator function, make sure it cannot equal 0 at any value for x, because you can never divide by 0. So that would indicate this on the number line. It would go from negative infinity up to minus 1, can't be minus 1, pick up just past minus 1 with the parentheses here, to plus 1, can't be plus 1, and then plus 1 to positive infinity. Okay? That would be how you'd represent the domain of the whole function now. Not just the denominator, the entire function has to follow that requirement. Okay. Now, that's what they're going to get at next. The domain of the arithmetic combination of functions f and g consists of all real numbers that are common to the domains of f and g. Now, the ones we were just dealing with were all polynomial functions. What's the domain of a polynomial function? All real numbers. Okay? So there were no restrictions there. Except when we got to the division, now it's no longer all real numbers. You have to, because that's now what we call a rational function. We haven't gotten there yet, but we will. So in the case, so the domain of arithmetic combination consists of all real numbers that are common to the domains of f and g. So if f was restricted on the domain, say to be from negative infinity to minus 1, and g was restricted on its domain to be from minus 5 to plus 17, what would be the domain of the sum, the difference, or the quotient, or the product of those? From, what did I say, minus whatever to minus 1, okay? Minus 7 to minus 1, okay? Because it has to be common to both. Can't be the stuff out there if that wasn't in this one. Can't be the stuff out there if that wasn't in that one. So it has to be the stuff common to domains of both of those. We'll see that a little later. Now we're just dealing with polynomial functions. But in the case of the quotient function, there's a further restriction. The denominator cannot be equal to 0. No values of x can cause that to equal 0. Okay. I probably should have said this earlier. Apologize for my voice today. I went to the UAB football game last Saturday, so I yelled too much. Okay. wife gets very irritated. Okay. But she doesn't hear well now. Okay, never mind. I didn't say that. Okay, so here's what the rules are for the sum, difference, product, and quotient of functions. We have f and x, f and g. Okay, don't pull it all the way because they didn't unlock it this morning.
Roteach.
Huh?
I'm on Roteach.
Say again.
I'm on Roteach.
Okay, got it. Okay, good deal, folks. All right, we're on page 76. It's chapter 1, functions of the graphs, 1.8, combinations of functions and composite functions. We're dealing with combination of functions now, and that's what we have here. The sum, difference, and product and quotient of functions. If f and g are any two functions with overlapping domains, something in the domains in common. If the domain of one is down here, the domain of the other is up here, nothing in common, you can't add them. You can't subtract them. You can't multiply. You can't divide because they have no elements in common. But if they do have some overlap with their domains, then for all x's common to both domains, the sum, the difference, the product, and the quotients of f and g are defined as follows. And it's pretty simple. Hopefully just what you would expect. The sum function, a new function, f plus g of x, is simply f of x plus g of x. I mean, can you get any simpler than that? The new difference function, f minus g of x, is f of x minus g of x. Straightforward. The new product function, fg of x, is f of x times g of x. And the new quotient function, f divided by g of x, is f of x divided by gx, but now you have to exclude any values for x in g that would make the denominator 0. Not only are you exclude them from g, you exclude them from the new function as well, because you can never divide by 0. Okay. It's a lot of blah, blah, blah there. Let's actually do some. So given that f of x is equal to 2x plus 1, g of x is equal to x squared plus 2x minus 1, find f plus g of x. Okay? Let's start with the domains. What's the domain about? All real numbers. Domain of g? All real numbers. So no limitations on the domain at all. They have everything in common. So let's find out what f plus g of x is. What would that be? What would it be? F of x plus g of x. It's that simple. Okay? And then write down what f is. 2x plus 1 plus x squared plus 2x minus 1. Now notice in the book, they put parentheses around it so you can tell this is your f and this is your g, but that doesn't help you in adding them at all, so I just left them off. Okay? So, what would you do next? Yeah. Combine like terms or common terms. Let's start with the highest degree. What's your highest degree here? The 2. How many quadratic terms do you have? Just that one, so just write down x squared. Next. Plus 4x. Combine the two linear terms, and then that's it, folks, because plus 1 minus 1 is 0. Okay? That's it. That's your sum function. Okay. Now, so this is f plus g of x. Okay? Now it says evaluate that new sum function when x is equal to 3. So what's f plus g of 3? What would that be? Doing what we did earlier. Think Glade. Plug it in, plug it in. And what would that give you? 3 squared plus 4 times 3. That would be 9 plus 12 equal 21. Perfect. I want to show you something, and hopefully this makes sense, and it's nothing new. What is f of 3? Say again? 7. Everybody see that? 2 times 3 is 6, plus 1 is 7. What is g of 3? 9 plus 6 minus 1. And that would be 14. Now what's 7 plus 14? 21. Okay? So you can do it either way. Since the two are equal, since f plus g of x is equal to f of x plus g of x, you can either plug it in and then combine, or combine first and then plug it in. I call it plug and chug or chug and plug. It doesn't matter. Do whichever is easiest, that you see best, whatever. Okay? Gives the same answer. All right? Any question on that? How'd the book do? Wow, they got it right. Good for them. Okay. So let me erase what I did, and let's see how they did it. The sum of f of g is simply the new sum function, f plus g of x is f of x plus g of x, and then they put in parentheses 2x plus 1, that's your f of x, plus the x squared plus 2x minus 1, that's your g of x, and frankly those parentheses do absolutely nothing for you at this stage, so get rid of them and combine like terms, and they just write down what it is. X squared plus 4x plus 0. Okay? First part pretty easy, just like we did. Then, when x is equal to 3, the value of the sum is, just plug it in. This is your f plus g of x, so plug in f plus g of 3. So put 3 squared plus 4 times 3 is 21. I didn't show how they got it, but they got it. All right. Any questions on that? Guess what? Every example followed by a checkpoint. Please do the checkpoint as soon as you can after class, just to refresh, enhance, and make it yours. Okay? So let's move on to, oh, look at them. Shame, shame on them. They skipping every other example. All right, so let's do example 2. Example 2, for f of x equal to x plus 1, just like before, and g of x equal x squared plus 2x minus 1, just like before. This time we want to find f minus g of x. And how is that defined? Anybody? F of x minus g of x. Pretty straightforward, right? So you write them down that way. The f of x is 2x plus 1. You could put it in parentheses. It'll do absolutely nothing for you. But then you have a minus. But this one you'd better put in parentheses because that minus sign there. So it'll be x squared plus 2x minus 1 in parentheses. So clear your parentheses first. What do you get? Leave the 2x plus 1 alone. And then what do you get? Negative x squared minus 2x plus 1. Excellent. Y'all are good at this. Okay? What does that give you? Negative x squared plus 2. Your plus 2x minus 2x added to 0. All right? Now, any questions? Everybody see it? All right, good deal. Then it asks for, then evaluate the difference when x equal 2. So f plus g of 2 would then be minus 2 squared plus 2. Now comes the issue, folks. This is one place where people will trip get tripped up. And by the way, if you haven't heard before, minus signs are only there to trip you up. That's their whole purpose in life. So what do we do with this? What is?
Square it first.
You square it first, because please excuse my dear Aunt Sally, and you treat this as a Sally, and that's an excuse, so do the excuse first. So it's minus what? 4 plus 2 is minus 4 plus 2 is equal to negative 2. All right, how'd they do? Very well, thank you. Okay. Any questions on that? Okay. Again, it's followed by a checkpoint, so please check your checkpoints. All right. Any questions? Everybody got it? All right. All right, to erase. Anyone still writing? Okay, I'll hold on. Everybody got it? Okay. All right, example 3. New functions. F of x equal x squared. G of x equal x minus 3. Find f g of x. What in the world does f g of x mean? Multiply f of x times g of x. That's it. And f of x was x squared times, and what's g of x? X minus 3. Now, when you have a monomial, like we do here, it's not necessary to put it in parentheses. You could if you wanted to. The f of x is just x squared, so I didn't. I don't like writing any more than I have to. But the binomial, good idea to put that in parentheses. And when you multiply those two, what do you get? X to the third minus 3x squared. Then they say, evaluate the product when x is equal to 4. So we want to do fg of 4. And what would that be? Whoa. Tell me first what it is. Write it down. 4 cubed minus 3 times 4 squared. I can't write, okay? Ooh, erase too much. Okay, that looks a little better. What's 4 cubed? Anyone know? 64. Minus 3 times what's 4 squared? 16. So that's 64 minus what's 3 times 16? Ooh, 48. And 64 minus 48 is? Say again? I can't hear. 16. Okay, I thought that's what you were saying. All right. Now, that's a lot of big numbers there. I would have been tempted to come over here and say, what were we plugging in for? F of 4 is equal to 16, and G of 4 is equal to yep. It's what?
4 minus 3.
Yep, is 1, and 1 times 16 is 16. That's a lot easier in that case, isn't it? Okay, so sometimes it's plug and chug, and sometimes it's chug and plug, okay? Wound up with big numbers there. But it's okay, we don't mind big numbers, do we? They're fun, okay. Again, there's a checkpoint. Please do your checkpoints. All right, that was example 3. Now we move to example 4. Now, I should have been asking this on every one of them, but every one so far has been a polynomial function. Domains, all real numbers everywhere. But now we get to the division, so we have to watch out for that one. So let's clear. All right to clear? Everybody got it? Okay. Let's do what happens with our division. Find f divided by g of x and g divided by f of x for the functions f of x, oh look at this, equal the square root of x, and g of x is equal to the square root of 4 minus x squared. Then find the domains of f divided by g and g divided by f. Okay? Frankly, I think we ought to at least establish our domains to begin with. Not for the quotient, but for the functions themselves. What's the domain of f? F is square root of x. Second? Okay. What's the square root of negative 3? Ooh! Huh? All numbers greater than or equal to 0. Okay? So, oh, get out of there. Okay. So this will be the domain of this. Do you like set notation or interval notation? I don't really care too much. Interval's a little easier here. Want to do it? What would that be then? Bracket, 0, positive infinity. That's it. Now, G. What are we going to do with G? What's our restriction here? Whatever's inside that radical has to be greater than or equal to 0, right? So let's do it. What's inside the radical? 4 minus x squared, and we know that has to be greater than or equal to 0, right? Now, we have to figure out what x is, because that's what our domain is. So this is domain of G. I didn't write it down. Domain of G. Okay? What you reckon you would do first? Did I hear? I thought someone whispered something. Factor it? Ah, good idea. How does that factor? Second? 2 plus x times 2 minus x. That product has to be greater than or equal to 0. Okay. This kind of stinks, doesn't it? Okay? Here's the problem, folks. For a product to be positive, when can that happen? When can a product be positive? When both of these are positive or when both of them are negative. So we got two conditions here. Either both of these have to be greater than or equal to 0, or they both have to be less than or equal to 0. Okay? So let's take, which one you want to do first? Huh?
2 plus x.
Okay, yeah, but which you want to do? The product both positive or the product both negative? You pick. Positive, okay. So we'll start with 2 plus x has to be greater than or equal to 0. And remember, when you get to deal with this inequalities, the 2 minus x has to be greater than or equal to 0. They both have to be positive. Okay? So, what do we do to solve this? For x, subtract 2 from both sides. Okay? And what does that give us? X is greater than or equal to minus 2. Okay? How about this one? Solve for x. What would you do? Subtract what? Huh? 2 from both sides. Okay, subtract 2 from both sides. And what does that give us? Negative x is greater than or equal to negative 2. But I'm really not interested in negative x. I want to know what x is. So what do we have to do? Second? either multiply or divide by -1, right? And what does that give you? X and 2. Aha! Less than or equal to 2. Okay? Now, here's the deal with this. Anytime you add or subtract negative numbers with a directional inequality, it doesn't change. Positive or negative, it doesn't change. When you multiply or divide by a positive number, it doesn't change the sign. But if you multiply or divide by a negative number, you flip the meaning of the inequality. Either multiplying or dividing by a negative number flips that. So now we have that. Now remember, these are conditions that are ands. They both have to be true. Both have to be true. So let's do a number line up here. Okay? Here's a number line. Okay? We'll put a 0 in the middle, a 1, 2, 3, 4, 5, 6, 7, 8, a negative 1, 2, 3, 4, 5, 6, 7. Not very evenly spaced, but just pretend that it's okay. All right, this statement right here says that x has to be greater than or equal to -2. Well, -2 is right here. It can be equal to it, so I'll include that. So anything greater than or equal to -2. But this statement says that x has to be less than or equal to +2. Well, it can be equal to it, but then it has to be less than. Well, both conditions have to be met, so what do we have? Any x between minus and +2. So the domain for this one are, okay, when both of them are positive, our domain for g of x, that's all we're dealing with now, would be domain of g could be -2 to 2. Done. Okay? But we haven't done the other one. We could also have both of them being negative. So let's do that one. What would our equations be then? Okay, I'm going to cheat like crazy. Is that okay? All right. I'm going to wipe out just about everything I've done here except one little thing. Okay. This time, for both to be negative, our condition is that both 2 plus x has to be less than or equal to 0 and 2 minus x less than or equal to 0. They both have to be negative. Okay? Because if one was negative, one positive, they're not going to be greater than 0. They're going to be less than 0. Both negative, they'll be positive. Okay? And that first thing we do is subtract 2 from both sides, and that gives us x is less than or equal to -2. Over here, this wipes out, and this gives you minus x is less than or equal to -2, which then gives you x is greater than or equal to 2, right? When you divide by -1 or multiply by -1. Changes direction of inequality. Now we consider our number line. Okay, I'll have to do some erasing up here too. I'll regret that I did so much here. Okay, I think I got most of it. Okay, oh, that. Okay. Now, let's see what the first, and remember that's an and in there. For x to be less than or equal to -2, that would be the -2 here and everything to the left side of it, right? And at the same time, x has to be greater than or equal to +2. Now, what values fit both of those? What value is common to both? None. None of these values here are greater than +2, and none of these values up here are also less than -2. There is no. This is a disjoint set. So this does not give you anything. So our domain, indeed, has to be this one. All right, so the domain of f is 0 to infinity, and the domain of g is -2 to 2. So, if we were doing any other function in the world, besides dividing, what would be our domain for these, for adding, subtracting, multiplying, or dividing? Okay. We can go back to our number lines. And this is so messy. I don't know if you, oh, I didn't get my eraser to work. Okay. Yuck. Ah, there we go. I lost this. Okay. All right. Domain of F for us from 0 to positive infinity. Everything up here. Domain of G was from -2 to +2. Everything in there. Okay, what's in common? 0 to 2. So for adding, subtracting, multiplying, the domain for F plus G, F minus G, and F times G would be 0 to 2. All right. Now, that was just to get our domains. We haven't even started on the problem yet. So let's get going on the problem. Let me erase some of this that we don't need anymore. Now I'm taking probably a bit too long to do this, but I want you to see it one time all the way through. What is your F divided by G? Here's your F, there's your G. F divided by G of X would equal the square root of X. 4 minus X squared. Okay. That's an ugly X, isn't it? Let me see if I can make that look a little bit better. All right. Now, what's the only new thing to enter our picture? We still are restricted. And let me get rid of some of this too, because we're through with it. Well, maybe not. Let's hang on to it for a bit. Okay. Now, what's the deal here? We're restricted. Oh, you can't have a what? Okay, we've already dealt with the negative, and negatives in the denominator are not a problem. Yes.
Can't equal 0.
Can't equal 0. Were there any values here which made, and remember, in our denominator we're restricted here, any values there that made that denominator 0? But we're really only restricted these values here, because we're not dealing with -2 to 0, because that was thrown out with here. So, any values from -2 to 0 that would make that denominator 0. I'm sorry, I said 0 to 2. Say it. 2. 2 would do it for us. So now, what you have to do, the domain of this function is going to be, oh, my pen has lost its mind. Okay, there we go. The domain of F divided by G of X would be, you can have the 0, you can have everything up to 2, but not the 2. So that changes the domain of your sum, difference, and product function would be 0 to 2. For your quotient function, you just have to lose the 2, because that would make your denominator 0. Okay? How about, okay, then the next part says, what is G divided by F of X? What would that be? The square root of 4 minus X squared over the square root of X. Now, again, we're restricted to this domain here. Is there anything in that domain that would be a problem down there. Yes, you can't have 0. So the domain of this one this is ugly, ugly, ugly. Okay, would be, you can't have the 0, but now you can have the 2. No problem with the numerator being 0. So now it's open parentheses 0 up to 2 close bracket. So the domain of f divided by g, lose the 2, everything else is fine. The domain of g divided by f, lose the 0, everything else is fine. All right. The combinations of functions were easy to do. F divided by g, g divided by f. That was pretty easy. It's the domains that get sticky. This one, the others, all real numbers, the simple ones, all real numbers, and then suddenly they threw one in that not only had one, but both of them, and the quotient have problems with it. Okay. But you worked them out really nicely. Make sense? Okay. See a few people still writing. And guess what that follows example 4? A checkpoint. So that's a real good one to go back and follow up with. And if you can't get the checkpoints, remember, you can go to larsonprecalculus.com, and there you'll see an audio video solution for that you can hear them talk about and do all sorts of stuff. So if you can't get it, don't get frustrated. And by the way, larsonprecalculus.com, no codes required, no passwords, nothing. Just go to the website. Nothing is required. All right. Everybody got it? Anyone else still writing? All right. Then we're going to, this was example 1 that we've already done. Now we're doing composition of functions. Okay? Now what do we mean by that? Another way of combining 2 functions, they do call it combining, is to form the composition of one function with another. Okay? Now this, I would guess, would be a fairly new concept for you. For instance, if f of x is x squared, okay, good function, and g of x is x plus 1, another really good function, the composition of f with g is f of g of x. So in other words, what you're operating on with f is no longer x, but g of x. Well, what is g of x? It's x plus 1. So it's f operating on x plus 1. Okay? But what does the f function do to whatever is in the parentheses? It squares it. Well, what's in the parentheses here? X plus 1. So guess what it does? It takes x plus 1 and squares it. Yes? Oh, the quiz? I guess it's Thursday. I don't know. Whenever you're finished with it, I'll take it. Okay? I don't want you to have to haul it around for extra time. If you're finished with it, I'll take it. If you're not, take your time and finish it. But work on it. Okay, by the way, did anyone here not get a quiz? Okay, 1. Okay, let me be sure I get you a quiz. I should have asked that earlier. I forgot, so I'm glad you asked. All right. Do you need graph paper or not?
Yes.
Okay. It's not really good high quality graph paper, but hopefully good enough for you to do it too. All right. This composition is denoted by F composed with G. Now, frankly, it looks like to me that's sort of foggy, doesn't it? But I think of it this way. I think of this as F of G. Now, that's not what that stands for, but that's a good way to think of it, F of G, because what is it? F of G of X. That's exactly what it is. It reads F composed with G, or the composition of F with G. F composed with G. But think of it as F of G. Okay? Here's the rule. The definition of a composition of two functions. The composition of the function F with the function G is F composed with G of X is exactly like I said, F of G of X. Okay. Now here again, boy, just like minus signs, domains are there to sort of trick you up sometime, aren't they? Here's what we mean by the domain. The domain of a composition is a set of all the X's that go into G. Not into F, but into G, because you start with the innermost function. All the X's that go into G, as long as F G of X is in the domain of F. So if anything went into G that produced something that couldn't go into F, then that has to be excluded too. So you start with all the X's in the domain of G, and then what G of X is, that has to be restricted to things that can go into F. So you may have to limit X a little bit more. Here's what they call a mapping diagram. And this is saying, oh my, okay. If you have X being in the domain of G, okay, then G of X maps over here. Now, only the values of G of X, because you see it's F of G of X, right? Then the output for G becomes the input for F. The range of G becomes the domain of F. But if there's anything here that can't go into F, then you have to restrict it and only do those that go here. And that gives you F of G of X. F of G of X, and that's the same as the composition of F of G of X. Now, to me, that diagram doesn't do a whole lot for me, but the key here is only the X's that are valid for G can be considered there, but then only the G's that are valid for F can be considered there. So if any G here, if any G of X produces a value that can't be used here, then that X also has to be removed from the domain. So it's sort of a two-step process, and it's not from Texas. So okay. So given f of x is equal to x plus 2, and g of x is equal to 4 minus x squared, let's find the following. Okay? Let's first do f composed with g of x. Well, tell me first what that means. What is the definition of f composed with g? F of g of x. Okay? So plug in. Always start with the innermost function first and work your way out. Okay? So that would then be f. You're not going to do a thing with f yet. You're going to put in g. And what is your g? 4 minus x squared. Okay? Now f does what? From up here. F takes whatever's in the parentheses and adds 2 to it. What's in your parentheses here? 4 minus x squared, and then you add 2 to it. That's what that does. What does this give you? -6 minus x squared, right? Add 2 to 4 and you get 6. Combine like terms, 6 minus x squared. That's your f of g of x. Okay? Now, what's your domain for g? All real numbers. And the domain of f would be all real numbers. So whatever g produces here, it'll go into that. So that's going to be good for all real numbers. Okay? Now, let's do the reverse of that. Okay? Now, they wrote it as minus x squared plus 6. But since they wrote this way, I wrote it the same. It doesn't matter. All right, what does G composed with F mean? G of F of X. And where do we start here? The F. So write the G down. And what is your F of X? X plus 2. And what does G do then? Starts with? Okay, starts with 4. So G of X plus 2 would be 4 minus X plus 2 in parentheses squared. We've got a little bit of work to do here, but we like work, don't we? Yes, okay. So what does this give us? 4 minus, so what's X plus 2 squared? Can y'all do that pretty easily? It's what? X squared. Second? Okay, I think you left off something. Now, what does X plus 2 squared mean? What does it mean? X plus 2, second, times X plus 2. You multiply it by itself, right? That's what squaring means, right? Now, how do you do that? FOIL it. What do you get? X squared. That part was right. Plus 4x. You double the cross term. Plus 4x. And then you get plus 4. Okay. Don't forget the cross term. Okay. Now we can remove our parentheses, and what would that be? 4 minus x squared minus 4x minus 4, and what does that give us? Minus x squared minus 4x, because these add to 0. Now, something to note here. F of g of x is not equal to g of f of x most of the time. What we say is the composition of the two functions is not commutative. It does matter what order you do them. So don't say, oh, well, I'll just do it this way. No, do it the way it tells you to, because they are not necessarily the same. Later we'll find some very special cases when they are the same, and those, like I said, are very special cases. They tell us something else about the functions. Right now, in general, F composed with G and G composed with F generally will not be equal. So let's do the C part here, and it says what is G composed with F of minus 2. Now there's two ways you can do this. How would you like to do it? Up to you folks. What do you do with Glade? Plug it in. So we've already figured out what F composed with G is, so you can just plug it in. That would be G composed with F of this of minus 2 would be minus a negative 2 squared minus 4 times a negative 2. Okay? And that would be minus a, what's negative 2 squared? 4. And what's minus 4 times minus 2? Plus 8. And that would be 4. Okay? You could do it that way. And that's pretty simple, straightforward. Or you could have done it this way. What does F composed with G composed with F mean? G of F of minus 2. Well, that's G of, and what's F of minus 2? Say again? Help me. How do you do that? Okay, negative 2 plus 2 is? It's what? 0. G of 0. Okay? And what's G of 0? Here's your G. I'm going to erase some stuff so you can see it better. What's G of 0? 4. G of 0 is equal to 4. And what was our answer? 4. Okay. Again, you can pay your money and take your choice. You've already paid your money, so you just take your choice. Either way you want to do it. Sometimes it's easier, just plug it in. And it was pretty easy to plug it in. Sometimes, though, it may be easier to do the evaluation and do it. Okay? It's all easy, isn't it? All right. I knew you thought that. Okay. So let's see how let's see. Let's watch how the book did it. Can I erase this now? Anyone still writing? Everybody got it? Okay. So let's see first, the composition of f with g is f composed with g of f is f of g of x, and that would be f of 4 minus x squared, which would be 4 minus x squared plus 2, because f says take whatever's in parentheses and add 2 to it. That's what we did, and you got minus x squared plus 6. Fine. That's what we got, only we did it 6 minus x squared. Same deal. Then do the b part, g composed with f, is g composed with f, is g of f of x. Plug in the f of x, g of x minus plus 2. Well, g says do what? Start with 4, subtract from it, whatever's in parentheses squared. That's what we did. And that gave us 4 minus x squared plus 4x plus 4, which is minus x squared minus 4x, which is exactly what we got. Note that in this case, f composed with g is not the same as g composed with f. In fact, in general it won't be. Occasionally it will be, but in general it will not be. Okay? And then using the result of part B, if you do it the long way, will be minus 4 plus 8 is 4, which is not bad. Or you could have done it the other way too. But we're running out of time, I think, by the zippers I hear zipping and unzipping and stuff. So where are we now? We have just done example 5. There is a checkpoint after 5. Please do it. We'll start next time with example 6, top of page 79. Homework exercises here would be number 3, which you can find at calcchat.com. Any of the odds, 5 through 11, they're all at CalcChat. 11's at CalcView. Do any of the odds, 13 to 23, they're all at CalcChat. 13's at CalcView. Do any of the odds, either 25 or 27, they're both at CalcChat. 25's at CalcView. Any of the odds, 29 to 33, they're all at CalcChat. 33's at CalcView. And any of the odds, 35 to 41, they're all at CalcChat. 35's at CalcView. And we'll hold off on graphing until next time, okay? Good deal. Any questions? Good deal.